At what angle in degrees should a ray of light be incident on the face of a prism of refracting angle 60 degree so that it just suffers total internal reflection at the other face? The refractive index of the material of the prism is 1.524. So let us understand this question. In this question, a light ray is incident on one face of the prism, okay, and the refracting angle of the prism is 60 degree. Over here, the angle is 60 degree. And what happened to the light ray? It just suffers total internal reflection at the other face. It will undergo refraction, and by striking the other surface, it just undergo total internal reflection. So this will be a refracted ray which will be grazing on the surface of the face. So in this case, you can see that if you draw a normal at this point, this angle, the emergent angle will be 90 degree. So if I draw a normal on the first face, this will be the angle of incidence. Let us mark this I1. This is R1 and this is R. Now, in this question, you need to find out the angle of incidence I1 such that the emergent angle is 90 degree. This is the given question. So, let us see how to solve this one. So, to finding the angle I1, you can use Snell's law. That is, if I use sin I by sin R, and I can connect it with the refractive index. So, N is equal to sin I1 by sin R1. From this, I can find the value of I1. But I don't know the value of R1. So, next is how to find out the value of R1. So for finding out the value of R1, you can see that in the derivation when we did for prism, we have already studied that R1 plus R2 is equal to A. I hope you remember this part. So R1 plus R2 is equal to A. Now you can see from the diagram what is R2 actually. R2 is the critical angle. That is why the refracted ray or the emergent ray in this case is grazing on the surface. R2 is the critical angle. And you know a relation connecting critical angle and refractive index. What is that relation? Sin IC is equal to 1 by N. So this is refractive index of the glass. So from this, I can find the value of R2. So let us substitute sin IC is equal to 1 by 1.524. So here we need to find out the value of sin inverse, and also I'll be directly giving the value. So IC will be equal to sin inverse of 1 by 1.524. If you solve 1 by 1.524, you will be getting 0.6542. And if you take the inverse of this one, it will be coming around 41. You can see that it is 0.6. So it is greater than sin 30 and lesser than sin 60. So that is why we are getting around 41 degree. Then after this, so IC is nothing but R2. So R2 is 41 degree. So what will be R1? R1 will be equal to A minus R2. You can write down A is 60, R2 is 41. So R1 is 19 degree. So we got the values of R1, and once you get the value of R1, let us substitute in the equation 1 to find the value of I1. So sin I1 is equal to N. What is that? 1.524 into sin R1. What is sin R1? Sin 19 degree. So once you simplify this one, you will be getting 1.524 into sin 19 is nothing but 0.3256. This value you can calculate in the table. So once you simplify this one, you will be getting the value of I1 as 30 degree. So this is a final answer. It's actually a very good question. In this, there are two concepts being checked. One is the relation connecting vertical angle, and we are using Snell's law, and we are using the other equation which we did during the prism derivation.